welcome to all. This is our class, most important class for moment of inertia with all concepts, and I told procedure earlier, today with examples. Part 3, standard expressions for moment of inertia about centroidal axis for different geometric shape. You can make a note here. Suddenly centroid, I used green color. I will tell the reason for you. I will tell the reason. Wait for some time. You should write all those one. Red color changed over to green. I will tell the reason. So see, colors also important here. That is IG. Your most important is IG, of course, and also another term. It is very simple. And area. See, not capital A. See, not IG. This is not your IG. Not IG and not total area. It is IG small letters. G is note. G considered not capital G. I will tell the reason now. Geometric shape means you can make a note, waste of time. One by one will come. Rectangle, triangle, three cases, triangle in general, isosceles triangle, right angle triangle, circle, semicircle, and quadrant of a circle. You write it. Rectangle first, triangle, three cases, triangle in general, isosceles triangle, and right angle triangle, circle, semicircle, and quadrant of a circle. Okay, now, first of all, there's a warning. Warning means not harsh language warning. Warning is for those who are semi-serious. Who are serious, they will follow everything I tell. Who are semi-serious, they will at least think, oh yes, I should study. Those who are not serious, leave it. Right now, leave the class. Okay. Class. So many concepts are there. Once this class is over, in this class, I will tell so many concepts. I decided sometimes I repeatedly tell same thing again and again. No, I decided not to go for it. I decided tell once. If not clear, you read 2 times or go through 10 times or 100 times or 1000 times. Your choice. Go through till you get perfection. And what all I dictate but not write, you have to write it. Okay, that's all. This is for people who really want to study from me. Okay, now, class. Why I using small g? See, when you make a note, see, start now. When you apply parallax theorem, I about any axis, red color, see, any axis I equal to Ig plus A square. Today's class, we are clarifying these two. This will come later, see. This will come later. This will come in next class. Next class, that is class 4. Part 4, that is part 4. Today you don't worry about it, part 4. So today you write here class. Today what you are covering is for different geometric shape, rectangle, triangle with 3 cases, circle, semicircle, and quadrant of a circle, how to get I about its own centroidal axis. Axis passing to centroid of only that area. That's why small g. This I told you earlier. That's why it is small g. Plus area is very simple. These two I am covering. So what all I tell, you have to thoroughly go through, understand, make a note, and be perfect. At the end of the class, you should see that when you apply parallax theorem in future, you have no difficulty for deciding Ig and deciding A. H will come in the next class, part 4. So that's all. Furthermore, I won't tell. Warning means people who are serious. No, not serious. Now, I'll remove this one now. I will first start one of them. Within no time it will be over. See. First I will consider one by one correct order. See. First consider, if I tell rectangle, it is rectangular area or rectangular lamina. You told it. First consider rectangle. Rectangle. See. Let B be the breadth, or some people call width. Capital D be depth. Some people call even height also. Okay, no problem, height. See, this is a rectangle. Right here, little this side. See, now see, this is a rectangle. This is B, this is D. I write here, this is D, depth D. Now, I want area. Area equal to A equal to B into D or D into B. Anybody will understand that one. Okay, that's over. Now, we have to locate centroid. See, don't by heart, make a note here. Don't by heart, B is horizontal, D is vertical. This is breadth and depth as per the class. I am marking in the class horizontal breadth, vertical depth. Okay, now, see. Now, this is actually later, this is going to be a component. So, its centroid is here, small g. See, small g, centroid. This is axis, centroidal axis. This also is centroidal axis. Now, okay, I will do one thing. I will mark D this side. Okay, this is D. Therefore, everybody knows, locate centroid. See, from here to here is D by 2. This also is D by 2. Width-wise, this is B by 2. This also is B by 2. So today's class, I am not writing x, x, y axis, nothing. I will write side by side, write a note here. In today's full class, I won't mention x, x, y. Side by side the axis, I will write moment of inertia. Okay, this clear. Now, make a note here. For a rectangular section or rectangular area, anything, I, moment of inertia I, about any centroidal axis is side parallel to axis multiplied by side perpendicular to axis, that one to be cubed divided by 12. So you can write parallel side. So with respect to axis, parallel side into perpendicular side cubed by 12. For that matter, make a note here. For rectangle and a triangle also, the cubing is always for perpendicular side. Parallel side will come as it is, no power. Parallel side will come, side parallel to axis will come as it is. But side perpendicular to axis will be cubed. Make a note here. You should write red color. Make a note. You write that much. Which side is parallel to axis will be as it is. But which side is perpendicular to side axis, that is to be cubed. Okay, now if that much data is there, anybody can tell, see, this IG means I through G, this way means parallel to B. See, for this axis, parallel side is B. So it is directly B is the parallel side into D cube divided by 12. And this I we want, this IG. Both are called IG only. And this IG, I about passing to center, about an axis passing to centroid, but parallel to C, parallel to D. For this axis, parallel B, perpendicular to axis is D. For this side, parallel is D. It is D into B cube by 12. Okay, crystal clear. Now, just one numerical example. Waste of time. Example. See, you consider rectangular area where, right here, numerical example. let the side be 250. Let the total depth be anything 360, some random number. Okay, then first write area. Area equal to 250 into 360. Okay, area is clear. Mark it centroid. See, centroid is here. G, small g. This is centroidal axis parallel to 250. This is centroidal axis parallel to 360. Now, if you want distance wise, this distance and this distance both are 360 by 2. This also 360 by 2. This way, this and this both are 250 by 2 and 250 by 2. This is clear. Now, I want IG, I about this axis. Also, I want I about this axis. See, last time, I won't tell once again now. What I am telling, listen correctly now. Okay, start. I about this centroidal axis. For this axis, you write here, some number you write here. For you write statement here. For this axis, parallel side is 250. So 250 into perpendicular side is 360 cube divided by 12. This IG for this centroidal axis, parallel side is 360. So 360 into perpendicular side is 250 cube divided by 12. If still not clear, not fit for studying. Okay. This is for rectangle. This is actually just given, so the example is not required. Okay. Now, the most serious part, triangle, circle, circle is very easy, semicircle and quadrant. But for triangle, 3 cases. This class is going to be lengthy class. That's why yesterday I have not uploaded. I am recording in 2 parts. Yesterday partial, today partial. Okay, now start. Now I will change over to now rectangle over. I will start now triangle. After triangle is over, I will go for circle. Triangle, 3 cases are there. Everything, once again be careful, warning. I removed the warning. Each and everything I tell you should write and understand. Then only you will get that the required knowledge or your structural knowledge will then only will improve. Otherwise, what I can do? Okay, I'll continue. Now we will start triangles. Triangle here, already rectangle over. Now make a note. Triangle, sometimes there will be some confusion. Confusion means surely not for me. For majority of people, that regarding centroid or regarding moment of inertia, base height, sometimes confusion. In the beginning only I given a warning. I told warning means not harsh language. Warning means those who want to study from me go through everything. So in triangle, each and everything I tell, you have to make a note. Otherwise, you are losing, that's all. See, let B be the base and H be the height. And remember, height H is always perpendicular to base. Now, one important. You write here, in our class right now, when I give standard expression, I am taking base horizontal. See, I am taking base horizontal and height vertical. But in case the triangle is turned, see, for example, see here, in case triangle is turned, then what we call base, B, is this is base. Then base will become vertical, height will become horizontal. So, my symbol is B and H. Don't by heart horizontal and vertical. B, I will, in all the explanation here, I will keep B horizontal, H vertical. Okay. Then, triangle, there are 3 cases. I am going in the reverse order for some reason. See, general earlier all, correct order of is first is triangle in general. Then particular case, triangle in general, same thing, see, triangle in general, B1, B2. Okay. If B1 is equal to B2, each equal to B by 2, it becomes isosceles triangle. Lastly, simple one, right angle triangle. Remember, right angle triangle is the most important. This is the most important. Red color, most important. Okay. Now, these are the three cases. I am going in reverse order because once I explain this one and this one, you get more idea for that one. If I explain that one, doubts will come. So, when you study for moment of inertia, centroid I started first this one only. Now, in moment of inertia, I want reverse order. So, I have new cases. Case 1, right angle triangle. Case 2, isosceles triangle. Case 3, triangle in general. Make a note here. See, base B, height h. Centroid here. See, I told thousands of times for you. For triangle, for locating centroid, 1 by 3 and 2 by 3 will come. 1 by 3 and 2 by 3 is always measured from the base and measurement is along the height. I already told you earlier. I am not going to tell everything 3, 4 times, 5, 6 times. Repeatedly go through. Yeah, that 1 by 3, 2 by 3. See, I told you that is always measured from the base but along the height. See now, if I take this as the base, don't see this B. This is the height. Yes, our symbol is h. So 1 by 3, 2 by 3. Now, or if I turn here, if I look from this side, our h will become base then. Then height will become b. So 1 by 3 and 2 by 3. Oh, not h here. 1 by 2 by 3 of b. I don't know why I wrote h there. Oh, okay. 1 by 3 of b, 2 by 3 of b. Okay. Print mistake. This already I explained many times. Now, this is centroidal axis parallel to base here, or B centroidal axis parallel to H. You need this IG and this IG. Right mark means standard expression available. Standard expression available, therefore I will take up it later. This is introduction part. First you understand all the three triangles. Then I will do one thing. One by one I will start. Okay. Case 2, isosceles triangle. Remember I told you this is base here. If I draw perpendicular here, see, if I draw perpendicular from here, this will be exactly B by 2, B by 2. Or this side equal to this side, this angle equal to this angle, this side equal to this side. Base, height. Again, from the base, height-wise, 1/3 and 2/3 of h. Whereas along the base, see, now there is no height, see, along the base, because symmetry is there, B by 2, B by 2, exactly midpoint. No 1/3, 2/3 here, midpoint. Now, I about this axis, passing to centroid, parallel to the base, standard formula is there. Right mark means you write here. Right mark means yes, it is there. Then, one more centroidal axis here, vertical, see, centroidal axis perpendicular to the base or along this edge. For this, so many people are not knowing the formula. They don't use it. They divide into parts, not required. See, yes, derived expression is there. We derived expression, if you remember, h into b cube by not 36, 48. Anyway, derived expression is there. Therefore, for isosceles triangle also, there is no problem. I told my purpose of this class is to see that you are able to locate the centroid of the whatever you consider and get the expression for moment of inertia about both centroidal axes. Okay. This also no problem. Case 3, triangle in general means randomly, see, some base, some height, some base, some height. Now, centroid along the height is 1 by 3, 2 by 3. 1 by 3, 2 by 3. I written there. Okay. Then, along the base, there is a problem. Why? It is not center. This is the case when B2 is, we should write somewhere here. If I take B2 more than B1, centroid will shift this side. Okay, see, this formula is B plus B1 by 3 this is b plus b2 by 3. I am not writing for some reason. But if b1 is more, b2 is lesser, see, then this is b plus b1 by 3, b plus b2 by 3. It will come this way. Suppose b1 equal to b2, then both will come b by 2, b by 2. Okay, now, right here. This is centroidal axis parallel to the base. See, for this axis, a parallel side base is there and height is there. Yes, formula is there. Right mark. For both cases, see here also, expression centroidal axis parallel to base. Yes, expression is there. Another centroidal axis comes up. It can come either here or here. Centroidal axis perpendicular to the base or along the height, right here, perpendicular to the base or along the height. We want I about this axis. IG, question mark, IG, question mark. You write here, question mark means no. See, no, no. Expression for moment of inertia about the centroidal axis. See, you cannot decide whether it comes this side or that side, depending upon B1 and B2. There only doubt is there. So, along this axis, there is problem. Question mark means expression is not there. No, no. So, what to do? I write here now. So, you write all this. You write that side. There is no space. I am writing here. And I am dictating. I am not writing. So, what to do? What to do? So, once again start. Right angle triangle. About both centroidal axis, expression is there. Good. Isosceles triangle. About both centroidal axis, expression is there. Good. But triangle in general, when these two are different, expression is there only for moment of inertia for the axis which is parallel to base here. That is actually BH cube by 36, derived one. But when it comes to the question of I about centroidal axis perpendicular to base here, expression is not there. So what to do is, so best option is divide the triangle into two right angle triangles. That is, for both the cases, see, ADC, see, is a right angle triangle, and other one is ADC, AB is B actually here, okay, B. One is ADC, other is BDC and BDC. You divide into, then you will get once again this case. So divide into two right angle triangles, and then I will tell the procedure for you. And consider each of them separately. Because the moment you divide into two right angle triangles, for each of them, standard expression is there. But remember, this is only when we require IG, see, only when you require this question mark IG, that question mark IG. Now, one note here. By chance in a question, you require moment of inertia only about this axis. Nobody wants about this axis for some reason. Then division is not required. You can take full triangle because B into H cube by 36. But if you require about both the axes, then when you want moment of inertia about this axis, then division required. Therefore, to avoid confusion, what you will do is, if it is triangle in general, unless you require moment of inertia only about the axis parallel to the base, if this is not required, see, in a question, I required about this axis, yes, then this will come. If I about this from vertical anywhere, if vertical axis is not required, that is called IYY later, then you need not bother. But still I will tell, so many people get confusion, it is better to divide. So I will do later, when I solve the question, I will explain more and more. So make all this note, Now I will do one thing. Each case, right angle triangle, isosceles triangle, and triangle in general, I will give expression one by one thoroughly with all explanation, including numerical example. Get ready for that. Okay, now in detail start. Triangle, case 1, right angle triangle. Let B be the base and H be the height. Write a note in the class. I told you, in the class here, only one sketch given. He is marking B along horizontal and H vertical. It can interchange. Don't by heart that way. Okay, now see, base B, height H. That is, we are looking from this side. Now, area half base into height. Everybody knows it. Centroid. Centroid is always that side where area is more. See, this way, more area this side. Centroid nearby. 1 by 3, 2 by 3. This way, more area downside as per this sketch. 1 by 3, 2 by 3. And I told thousands of times, height is centroidal distance 1 by 3, 2 by 3 is always marked along the height. Therefore, right statement. When you consider the B horizontal dimension B as the base, height is H. So, 1 by 3H, 2 by 3H. Now, we want this distance. Do one thing. You turn. You take whatever H is there here, you take that as the base. Look from this side, right here. Look horizontally from this here. Look vertically up here. Look horizontally from side. From the side see it. When you see from side, then H becomes the base. Whatever I wrote H here, that becomes base. B becomes the height. So, 1 by 3B, 2 by 3B. Now, class, write everything. For a right angle, see what I told. For a right angle triangle, you should write. See, for a right angle triangle, I about any centroidal axis is base into height cube by 36. Remember, don't put BH cube. Base into height cube by 36. But remember, base is parallel to axis, height is perpendicular to axis. If axis is like this, parallel is B, perpendicular is H. And one more note, I forgot to tell you. Rectangle or any case of triangle. See, already earlier rectangle over. Today we are in case 1 of triangle. You write here. Already you make a note here. Already rectangle is over. I think I told there. And right now we are in the triangle. Right now we are in the triangle of case 1. That later case 2 will come, case 3 will come. Everywhere. That cubing word I don't know in English there or not. That cubing. See, cube. That cubing is always for the height. Height means don't by heart H actually. Cubing is always for the height that is perpendicular to that is the dimension. That is dimension perpendicular to the axis. If the axis is horizontal, cubing is always for vertical. You write here. You write what I am telling. If the axis is horizontal, you write. Then cubing is always for vertical dimension. If the axis is vertical, see, perpendicular to axis. So if the axis is vertical, cubing is for horizontal. I will not tell again and again. So, I about this axis, see, IG, this IG. For this axis, B is parallel. So, it is B into H cube divided by 36. Black I am writing. This IG, about this axis IG, see. Now, if you want about this axis, parallel is H. So, it is H into B cube by 36. Make a neat note, centroid is here, Yes, right angle triangle is over. I'll immediately give numerical examples now. This I'll remove now. This fully right. Okay, I'll go for numerical examples. Everything I'm covering. See, I'm not giving any chance for something skipped. So, right angle triangle, you write here. Numerical examples. Numerical examples. And one more thing, you should not by heart left side is 2 by 3, right side is 1 by 3. Okay, numerical example, I'll remember, I'll forget later, I'll make a note here how I'm taking. First this way, then this way, then this way, then this way. Okay, I made a note, otherwise I will forget the order. I made a note. First, numerical example 1. You write here, consider a triangle of horizontal dimension something. 60 millimeter. I told you for entire class, I won't waste time or waste ink. Whenever numerical dimension is there, all dimensions are in millimeter. It can be anything in my class millimeter. So area will come in millimeter square, centroidal distance will come in millimeter, moment of inertia will come in millimeter power 4. Okay, see, this is a triangle. Example 1, I will take here. 60 by this dimension I require 80 out of scale. Okay, 80 better. This is 60, little lesser, 50. Okay, 1. Numerical example 2. I will do one thing now. See, here left side to right side increasing. Here I will do this way. See, left side, right side decreasing. Actually, first of all, not required. Do one example 2. I will take the base some dimension, say 100, out of scale. Different scale, don't worry about scale. This sketch is separate sketch, 100 and 110. 110, okay. Numerical example 3, I will write here. Numerical example 3. See, I told you each and everything covered. Okay, little down at right, space problem there. This way. This dimension is anything 75 and this dimension is something else, anything, say 125. Numerical example 4, this way. Okay, now nobody can tell this is not covered, that is not covered. Numerical example 4. This height I will mark 250. Bigger. This I will take 250, say little lesser, 225. Okay. These are the numerical examples. Okay, start. First, instead of wasting time, area, I do not tell. Half into 60 into 50. Why? Green color. Area for this one. Area. Green color. Area is green color, but value is black color. Half into 100 into 110. You can write either half into 100 into 110 or half into 110, 100, whatever you want. For this one, area. Area. For this also you require area. Okay. Area. Half into 75, usually horizontal first, into 125. For this area. First of all, I don't know why I am wasting time. Area. Half into 225 into 250. Okay, no one can tell area is not covered. Okay, now centroid, see here. 90 degree here, 90 degree here, 90 degree here, 90 degree here. Centroid, divide into three parts, base and height. See, 3 equal parts, light line. This is how you should decide. See. Okay, then come to where 90 degrees is there. Near that side, see, centroid G. Centroid G. I forgot to divide here. Okay. Centroid G. Centroid G. Okay. Then mark distances. This is 2/3 of 60. This one, 1/3 of 60. This one, height wise, 1/3 of 50. This one, 2/3 of 50. Here, 1/3 of 100. This one, 2/3 of 100. Here, where to write? I'll write here. Okay. 1/3 of 110. This one, 2/3 of 110. Space problem is there. Here, 1/3 of 125. 2/3 of 125. I am dictating. If the letters are not clear, I am dictating here. You can hear. You hear what I am telling. 1/3 of 75. This is 2/3 of 75. Here, 1/3 of 225. 2/3 of 225. This one is, space is not there. 1/3 of 250. This is, space problem. 2/3 of 250. You do one thing. You shift 250. I'll do that one. Why confusion? Okay. Why unnecessary? I'll shift 250 here. Okay. Now space is there. Why? Make it neat sketch. And now crystal clear. See. 1/3 of 250 and 2/3 of 250. Okay. Centroid located. Now, through centroid, one axis here. One axis here. We want this IG and we want this IG. This IG we want. Here, two centroid, one axis here. We want this IG and one more centroidal axis here. We want this IG. Okay. And one more here. We want this IG, we want this IG. This all important now. We want this IG, no name, no XXYY, this IG we want. Okay, start. Here, this IG, parallel is 60, that's all. 60 into 50 cube by 36. This axis, for this axis, parallel is 50. Start from there. 50 into perpendicular is 60 cube by 36. Come here. For this axis, parallel is 100. See here. Space problem is there. Right here. This IG. Okay, this IG. Parallel is 100. I told you, cubing is always for perpendicular. 110 cube by 36. This IG, parallel is 110 into perpendicular is 100. 100 cube by 36. Correct? Huh? Anything wrong? 60 into 50 cube by 36. 50 into 60 cube. Correct. 100 into this IG. 110 cube. 110. Here, this IG. Parallel is 75. 75 into 125 cube by 36. This IG, parallel is 125 and perpendicular is 75. 120. Cubing is always for perpendicular. Parallel side as it is. See, parallel dimension is as it is, perpendicular to be cubed. I will not tell once again. By 36. Here, this IG, for this one, parallel is 225. 225 into 250 cube. I'll check the camera later. Divided by 36. This IG, for this one, parallel is 250. 250 into perpendicular is 225. 225 cube by 36. Correct, Allah? 250 for this IG. Sometimes what happens is writing suddenly 225 here, 250, 75, 125. Now anybody, if this is not clear, you stop continuing my class. You go to some other person who got a better knowledge than me and better way of teaching and who better way of teaching or knows much more than me. Go there. Sufficient. If still it's not clear, what I can tell. Okay, now right angle triangle is our answer is not required. Now I'll go for case 2. Case 2, I write now only. Isosceles triangle. Isosceles. Sometimes spelling problem will come. I am not very good in English spelling. I get some doubt. If English spelling mistake is there, don't. My mother tongue is not English. Up to SSLC or 10th standard, I studied in Kannada medium. Only after coming to pre-university course, PUC, it started English. My English control is not bad. See, grammar mistake I never make. Very rare. Spelling mistake sometimes it happens because who will by heart everything? See, isosceles. Yes, correct, I think most probably. Sometimes I get doubt. S comes or C comes. E comes or not. Such cases. Or double L or single L. In such cases, whatever comes to my mind, I will write. You don't bother about spelling all. You worry about subject. Okay. Now I'll come to case 2. I'll prepare first to save the time. Now come to triangle, case 2, isosceles triangle. Let B be the base and H be the height. Class, you should write. He is marking horizontally B and vertically H. Don't by heart that way. If I turn it, vertical becomes base, horizontal becomes height. So B and H and words BASE and HEIGHT are different. Okay. And then, okay, start. Isosceles means I told these two are equal. If it is base B, B by 2, B by 2, height H. I told thousands of times. Centroidal distance is 1 by 3 or 2 by 3 measured from the base or vertex and measured along the height. So 1 by 3, 2 by 3, you know it. This is already told thousands of times. And this way, centroidal axis comes exactly center because midpoint. Why? There is no 1/3, 2/3, center here. So this is B by 2, B by 2, 1/3, 2/3. Now, right here, you should write something. I am dictating. This IG, for this IG, this is the base parallel, height is H. Oh, perfectly triangle. For this axis, see, base defined, full base defined, full height defined. So, usual, right here, BH cube by 36. BH cube by 36. But this IG, be careful. Class. This IG is about the centroidal axis which is parallel to H and perpendicular to base. So one thing sure, see, for this IG, parallel is H. You should write what all I am telling. See, for you write here, for this IG, parallel is H and perpendicular is B. So 100% cubing is for B. B to be cubed. But remember, this is not the base. You write here. Here, this is common base for either side two right angle triangles. Now, one more note you write. One more note you write. See, one more note. See, that base into height cube by 36. You write not base, you write words only. You write base into height cube by 36 is when base is at the extreme end. Base should be extreme edge. See, yes, correct. See, base is extreme edge. Correct. This is not valid if the base comes in between or if that base is common base for either side triangle. See now here, this is not the base for the entire triangle. See, it is not extreme, it comes in between. Or right here, this H is the base, if you look this way, for a triangle this side of height b by 2 and also for a triangle this side of height b by 2. Or this H, see, this side is not the base for the full triangle. In that case, if it is isosceles triangle, if it is general triangle, no formula. I told you, no formula. If it is isosceles triangle, formula is, see, if you want I about this axis, which is parallel height, which is parallel height, right? See, for this I right here, for this IG, you write all the statement. Parallel is H into perpendicular is B, but B cube by not 36, be careful, 48. This is derived by us, and it's a special formula, remember. So BH cube by 36 is for whenever the base is the extreme, see, whenever the base is at the extreme, either bottom extreme or top extreme, see, even this also will do, see, base is here, but HB cube by 48 is when that base is somewhere in between and exactly center. But if it is a general triangle, you can't do it. So for this I, this is not the base for full triangle. So we derived in the class, the expression is for this I, parallel is H into perpendicular side is B cube by 48. Remember, over. Okay, now come to numerical example. Okay, I wrote earlier, see, 400, 200, 200, 1/3, 2/3, I wrote. Tell the answer here. For this I, Ig equal to, see, for this Ig, your base is here. And yes, it is an extreme here, so no problem. 400 into, how much height? 300 cube by 36, usual number. But this Ig is, parallel is 300 into perpendicular is 400, 400 cube by, be careful, by 48. Suppose you got difficulty, you can do one thing, divide into two triangles and go, see, suppose you do not want this one, then do one thing, divide into two triangle, right angle triangle, then do it as per the next case. Okay, now, example 1 is over, I'll go to example 2, here only. Okay, I finished the upper triangle, see now, fast I write, don't waste time. Example 2. This color problem for me, see. You have, I tell the students always, you have subject confusion, example 2. I have got a color confusion. This way. See, I am covering each and everything. This is some number, say 400, 450. If it is 450, these two are 225, 225. Because why? Isosceles triangle. 225, 225. Some height required, I will mark height as little bigger, 500. Okay, start. Area, I see last time I wrote the area, first tell area. Area equal to half into 450 into 500. If I don't write next time, leave it. You write yourself only. Okay, start. Now, see here. This is the base, this is the height. Centroid is here. If I mark height wise, see, 1/3 of 500, this way is 2/3 of 500. Whereas this way, it is exactly midpoint. This is the axis, the special axis. Remember, this is the special axis, Ig required. And this is your regular axis, see. This is your regular axis, Ig required. Right here. This Ig is usual, see. This is the base, extreme edge base. So, how much it is? 450 into 500 cube divided by 36. But this Ig is, see, this is the base, not extreme here, in between base. It is a base, common base for either side, two right angle triangles. So parallel is 500 into perpendicular is 450, 450 cube divided by 48. Okay, this is second case. Next, example 3. You can see how seriously I am conducting the course. I may forget later. Okay, first I will do this way. Okay, this way. Because sometimes I forget it. This way, see. Example 3. Okay. This base, not base, vertical dimension is 145. And this height is, I will mark here some random number, 115. Okay. Then this distance and this distance is half of. Half of means 72.5. See, this is 72.5. This also 72.5. Isosceles triangle. Correct. No, correct. Okay, now see, area first. Area half into 145 into 115. Area over. Now, see, now this becomes base, this becomes height. So centroid is here. So this distance is 1/3 of 115. This distance is 2/3 of 115. Whereas this way, see, this is your centroidal axis parallel to base. This way, centroid is exactly midpoint G. Now see, for this axis, your IG is, for this axis, parallel side is 145, base is 145. Yes, it is the extreme edge base. So turn it. It is, base is 145 into 115 cube divided by 36. But remember, I about this axis, this IG is, this is not the base here. See, you can, if you look from side here, this is the base for either side two triangles. It is not extreme base. So it is, for this I, parallel side is 115 into the perpendicular dimension is 145 cube divided by 48. Okay. Example 3 over. Now example 4, I will take this way. Okay. And what I am doing, I am not leaving anything. Example 4. So tomorrow, see, when you solve a question, anything can come. How? This way. Okay. See here. This way is there. This way. This side, imagine, is 150. This you imagine is 250. Some number. Okay, 250. Now, see here. This is the base, this is the height. So centroid will be somewhere here. See, centroid will lie in this axis, symmetry axis there. See, this, one thing in the question only given here. Why? How you know isosceles triangle? This is given in the question only, 75, 75. So centroid is here. Centroid is here, G. So this distance will be 1/3 of 250. This distance will be 2/3 of 250. Now, there is one centroidal axis here, one axis here. Okay, start. This centroidal axis, IG. For this centroidal axis, parallel side is 150. It is the base, and that base is extreme base. So direct formula. How much? Usual. 150 into 250 cube divided by 36. But this IG, for this IG, this axis, this is the base common for either side. So it is not the extreme base. So special formula, anyway, when you want this I, parallel is 250, that is correct. Parallel into perpendicular, that format is always same. Cube divided by 48. I forgot to write the area. Okay, let area also. Half into 150 into 250 is the area. Okay. Now, isosceles triangle is over. Now I'll go for the most important triangle in general when these two are not equal, or here see, these two are not equal. Little lengthy it will become. I'll thoroughly cover it, but I'll prepare first. Now come to very important, little tricky triangle in general. Means, see, once again, let B be the base and H be the height. Make a note. In this class, he is marking B horizontal, H vertical. If you turn it, that it will change as per the sketch in the class. Then, area, total area equal to half into base into height. Okay. Now, centroid location, see. Centroid, see, if this is the base, this is the height. Along the height, 1 by 3h, 2 by 3h. But along the base, centroid will be sometime this, see, this point I will take D. Sometime it will be, now it is this side because I have taken B2 more than B1. Or if B1 is more than B2, it is this side. Or this centroidal distance, see, this centroidal distance, question mark. It is not question mark, you write. Question mark means you know it. What formula is there? B plus B1 by 3 from here, B plus B2 by 3 from here. You write all these things. But right, by chance you locate centroid, there is going to, all I am going to tell you right, there is going to be problem later. Because if you want this IG, see here, this IG, no problem. Why? For this IG, parallel side is base, height is H, BH cube by 36. We derived it. But see, this IG, no standard expression. Why? First of all, see here, for this one, fully you don't know, first of all, it will depend on these distances. Therefore, question mark means even if you calculate, it is of no use. Cut it. No use. So, make a note. I will not tell once again. This IG, no standard formula. So, what to do? Therefore, I will tell you now what to do. 1 minute now. I will tell what to do. Therefore, see, red color I will write. Therefore, see here, red color. Divide the triangle into given triangle. See, divide the full triangle. You write here. Divide the given triangle into two right angle triangles. Namely, ADC and BDC as shown in the next sketch. Okay, now 1 minute. Okay, divide it. See now, when you divide here, this base is B1, that base is B2. See, right angle triangle. Centroid. Now you can put centroid because for this triangle, see here, this is 2 by 3 of B1. This is 1 by 3 of B1. And if you go for that side, this is 1, because why? It's a right angle triangle, see, 1 by 3 of B2, this all explained for you. This is 2 by 3 of B2. And height wise, this is 1/3 of H, 2/3 of H, 1/3 of H, 2/3 of H. No, see, G1, G2 vertically here will remain same. So this 1/3 H, 2/3 H I wrote here is common for both. See, you can use these two for this one and also for G1. It is common for both G1 and G2. Right here. It is common for both G1 and G2. Okay. Then, now write. Now find moment of inertia separately. Start. See this right angle triangle. If you want, now there is no problem right here. Now there is no problem because we got right angle triangle. See, start. For a area, this area is half into B1 into H. That area equal to half into B2 into H. For this centroidal axis, see, parallel side is B1 into H cube by 36. For this one, it is parallel side is H into B1 cube by that IG1. This IG1 means about this axis, that IG1 means about that axis. This is IG1 parallel to this side, that is IG1 parallel to that side. Okay. Same way here, see, this IG is parallel side is B2. B2 into H cube by 36. This IG is H into B2 cube by 36. Now, those who want to make a note, by chance, your purpose in any question, if that YY axis, see what you can see like YY axis, if that I is not required, if you want only I about horizontal axis, then this I plus this I will be, see, B1 H cube by 36 plus B2 H cube, you should write here, B2 H cube by 36 equal to B1 plus B2 into H cube by 36. But B1 plus B2 is B. Once again you get BH cube by 36. Make a note. This should be what all I told here. Thoroughly understand. Now I will go for, once again, 4 numerical examples, one by one. 4 numerical examples. See, case 3, triangle in general, I write very, very important. 4 numerical examples. 4 I will cover. Numerical examples because very, very important examples. Okay, start one by one. I will write and then explain. So, case 3, triangle in general, 4 numerical. First numerical, see, 400 by 250, 120, A, B, C, D. Write what all I tell for all the 4 examples. I will tell here now. Divide the given, write reasons already told for you. Now I won't waste time because there is a problem for moment of inertia about the axis which is perpendicular to 400. See, parallel to 400, no problem. 400 into 250 cube by 12. But the problem comes for the perpendicular. Therefore, already explained how many times. So write everything. Now I won't tell. All the 4 times you have to write. Divide the given entire given triangle into 2. See, divide given entire triangle into 2 right angle triangles. Say ADC and BDC and separately show. Oh, I forgot one thing. Last time when I put for B1, B2, I forgot to mark 1 and 2, I think most probably. See, last time in the standard case, you write this side as 1, part 1 and part 2. When you do a problem, it can be any part. Today's class, it is part 1, part 2. So last time I forgot it now most probably. So the left side and right side, you mark 1 and 2. But I wrote IG1, IG2. Okay. Now see here. 120 by 250. If it is 120, this is 280 by 250 height. So height, see, G1, G2. Height wise for both of them, 1/3 250, 2/3 250. Common for both. This 1/3 250, see, 1/3, 1/3, 2/3, 2/3 of 250 is common for both 1 and 2. Common for both 1 and 2, you should write. But this way, see here, this is 2 by 3 of 120. This is 1 by 3 of 120. And here, this is 1 by 3 of 280. This is out of scale, 2 by 3 of 280. Okay, I forgot write ABCD. Okay, right here ABCD to confusion. avoid confusion, I will mark here A, B, C, D. Okay, then see now, right angle triangle. Area I wrote here. I won't explain area. Okay, start. About, see, this is IG1, this also IG1. This is IG1 parallel to 120. This is IG1 parallel to 250. Okay. IG1 parallel to 120 is 120 into 250 cube by 12. For this one, 250 into 120 cube by 12 already thoroughly explained. Now anybody will tell not clear means leave the class. Here, this IG2 is 250 into 280 cube by 12. This IG2 is 280 into 150 cube by 12. Crystal clear. Okay, now I'll do one thing. Now I won't pause. I will write here only. Where is that? Here. Okay. Now I'll go for example 2. Okay. Example 2. See. I'll take this side more now. It does not matter. This full is 150. And imagine this is up to here. See, A, B, C, D. This 150, half is 75, 90. And height is 90, 45. Okay. This is example 2. Okay, start. Write everything what I told earlier. Start. $90, $150. 90 here, that is 60. Okay, see, this is 90, that is 60. Some number 60. Height is 45. Okay, 45. Okay. A, B, C, D. Then common height for both. This way. 45. Now see here. This is your part 1. This is your part 2. Right here, part 1 and 2. Divide into parts. This is part 1. This is part 2. Okay. See. G1, G2. See, G1 along the height, G2 along height for both of them. But you break it here. See, when you mark here, you break that one. See, both of them, it is 1 by 3 of 45. This is 2 by 3 of 45. Right, common for both. You write there, common for both. But this way here, see, this distance is 2 by 3 of 90. This is 1 by 3 of 90 here. This is 1 by 3 of 60. This is 2 by 3 of 60. Now, see, centroidal axis here. Centroidal axis. Don't join those two. Separately, have a break in between. Okay. Okay, this is this way. Okay, right. I want this IG. Then I want this IG. IG1, IG1. I told this IG1 is I about axis parallel to 90. This is parallel to 45 here. I want this IG2. And also I want this IG2. Okay, start. Area I forgot. Okay, I should not write area. A1, half into 90 into 45. A2, half into 60 into 45. See, this IG parallel 90. So 90 into 45 cube by 36. This IG parallel to 45. 45 into 90 cube by 36. Here, this IG parallel to 60. 60 into 45 cube by 36. This IG parallel to 45. 45 into perpendicular is 60. 60 cube by 36. Everything correct? 90, 45 cube. 45, 90 cube. 60 about this axis. 60, 45 cube. 45, 60 cube. Okay, this is numerical example 2. Now, I am covering everything in single stretch only. To save the time, recording, editing becomes easy for me. Numerical example 3. Numerical example 3. Numerical example 3. How I write? Okay, I write here. See, this way, and this way. Okay. This is something 70. This full base is 100. In 100, this is one side given 65. Okay. I will put A here, B here, C here, D here. Okay. Start. What all I told, right? Two right angle triangles. What? ADC, yeah, that state. But each and every class I have to tell it. You write everything, what all I told. Okay, then start. Now this way more space required. Okay. 165 means 35. Okay. 35 here. Why? This is 100. This is 65 means 35 here. This is 65 here. Little bigger. 65 here. 35, 65. Okay. And height is 70 up to here. Okay. This is the two triangles. Okay, anyone you can take one, anyone you can take two. I'll do one thing now. See, I will take this as one. Yeah, that is 1 and 2, your choice. No restriction. You take whichever you want. Okay, this I will take 1. 1, blue, green color 1, green 1. This is 2. Hatch some other way. Okay, this base, how much it is? 35. This base, 65. Common height for both, 70. Okay, now only to save the time, A1, I don't want to waste time, A1, half into 65 into 70. A2, half into 35 into 70. Okay, forget about A1, A2. Now, see, this is the base, this is the height. Divide 3 parts, 3 parts. See, centroid here. This is your G2. This is centroid G1. Now do one thing, draw one axis here. Break it. Draw one more axis here. Break it. Don't continue. And for both of them, out of scale, what to do? I should have taken a little more. See, for both of this one, height is 70. Out of scale. Okay, 1/3 of 70. This is, I'm not happy. It should have been big. Okay, 2/3 of 70. Common for both. Common for both 1 and 2. But this distance is different. See here. This is 2/3 of 35. This is 1/3 of 35. This is 1/3 of 65. This is 2. I am not explaining much now because already some will feel boring now. And this is centroidal axis. See, there is one more centroidal axis here. Now we want this IG2. Also we want this IG2. We want this IG1. Also we want this IG1. See, correct, clear. IG1, this IG1. Parallel side is 70. 70 into 65 cube by 36. 36, correct? 7, okay, this 70, okay. This IG1, for this right angle triangle, this IG1, parallel side is 65. So 65 into 70 cube by 36. This IG2, parallel side is 35. 35 into 70 cube by 36. This IG2, parallel side is 70. 70 into 35 cube by 36. Okay, now last example, example 4. See, example 4. Some will tell, sir, we can understand. You can understand, no doubt, but I do not want anything to be left out. Now, how it is? This way. Now it is this way. This way. Huh? Last time I given this way only, correct? I forgot now. Yes, correct, this way. Example 4 is this way. That will be bigger there, smaller here. Okay. This full base is 180 and this distance is 90, 70. This height is 70, 80. Okay. I will take A here, B here, C here. I forgot last time. See, last time I forgot here. A, B, C, D. You write there last time. Okay, now A, B, C, this is D. What all I told earlier, write it. Okay, now this side. Okay, last over. Finally getting over. You don't know how much patience is required to give this much explanation. You should think of that one. Okay, start. See, if this is 70, this is 110. Okay, so here 110, then 70. 70. Height is 80, somewhere here. Okay. Okay. These are the two triangles. I forgot. A, B, C, D. Mark here, dimensions. This is 70. This is 180 minus 70 is 110. Common for both, see, common for both, I'll write here, common for both, this is 80. 80. You take this as 1, any one as 1, this as 2. This is your 1, this is your 2. See, centroid now. Okay, this is how much? 80. Okay, first before that one, A1. Someone will tell, area not written. Half into 80 into 70, A2. Half into 80 into 110. Okay, now, see, G1. G2. Now see, along the height, for both of them common. See here, common for both. 1 by 3 of 80, 2 by 3 of 80, you write common for both 1 and 2. But this way, see here, this one, from here to here, 2 by 3 of 110, this is 1 by 3 of 110, this is 1 by 3 of 70, this is 2 by 3 of 70. Now, I want, see, okay, I want this IG1. I also want this IG1. Then I want, see, this IG2. Lastly, I want this IG2. IG2 means different because orientation, IG2. Start. For this IG1, this triangle, this IG1, parallel side is 70. So 70 into perpendicular is 80. 80 cube divided by 36. Whereas for this IG1, parallel side is 80. 80 into 70 cube by 36. 80 into 70 cube. And here, for this IG2, parallel side is 80. 80 into perpendicular side is 110. 110 cube by 36. For this IG2, parallel side is 110. 110 into 80 cube by 36. I think everything correct. 70 into 80 cube. 80, 70 cube. 80, 110 cube. This is 100, correct. Now, after this example, if anybody got problem in future for a triangle, rectangle already over, then they should blame themselves only for not properly studying what all I told. Goodbye. Now, in future, when I explain moment of inertia, I won't waste time every time telling, see parallel side, perpendicular side, 1/3, 2/3, I will not tell. If you don't understand, somebody may comment, he is not explaining. I am not explaining. You are not fit to study from me, I will tell. You are not fit to study from me. You start from beginning, study everything. Those who are seriously studying, everything they will understand. Okay, now, last circle, semicircle and quadrant. Now, circle. Remember, when you do a problem, we always consider diameter. We don't consider radius. Diameter equal to D. C is the center, circle. Centroid G will coincide with center C. Area, pi by 4 of diameter square. IG, you make a note here. I will dictate for a circle, moment of inertia about any axis passing through center or centroid, that is about any diameter equal to pi into diameter power 4 by 64. So this IG and this IG both are equal pi d power 4 by 64. Area pi d square by 4. One numerical example, complete time waste. Imagine diameter 200, area pi by 4 200 square, both I pi by 64 of 200 power 4. Okay. Okay, now most important, semicircle and quadrant. This is where so many people get confusion. I will remove the confusion. See, now I will first tell you semicircle and quadrant. Together I will explain. Semicircle and quadrant. Quadrant of a circle. Actually, semicircular lamina and lamina in the form of quadrant of a circle, or circular cross section and or semicircular cross section, or cross section in the form of quadrant. Okay, now let D be the diameter and C be center. Remember, I told you center means not midpoint center. Center of the circle, if you continue all round and get a circle, this I told you earlier, someone will tell, for quadrant there is no center is there. I won't waste time on this one. Okay, now see, in the class I will show like this, semicircle like this. In the class quadrant, I will show, I think I derived like this, I think, correct? I don't remember. Okay, derived like this. Okay, no problem. So this way. Diameter equal to D. Diameter equal to D. This is center of circle. This is center of circle means if you continue center, see. Okay, now you should correctly make a note. Semicircle area equal to half of the, first of all, remember, you should note one thing now. In a corner, you have to make a note. In a corner, you have to make a note. I will tell you why. Corner, make a note. Circle area pi by 4 d square. And circle moment of inertia is pi d power 4 by 64. This you should remember. I will tell you now. Semicircle area is half that of circle. So instead of pi by 4, pi by 8 of d square. This is all already over. Quadrant of a circle area is, see, circle pi by 4, semicircle pi by 8, quadrant pi by 16 of diameter square. Area clear. Now come to centroid. Semicircle, see, don't by heart this way, it came another way. There is one axis of symmetry right here. For semicircle, there is one axis of symmetry. And this is your axis of symmetry. Quadrant of a circle, there is no axis of symmetry. So centroid lies here. So centroid will be somewhere here. Here, centroid will be somewhere here. This all we proved it. So this is centroidal axis. This also centroidal axis. We want this IG. We want this IG. Here. See, this is symmetry axis. This is centroid G. We want this IG. We want, see, this IG. Wait, right? Space problem is there. Okay, I write here. We want this IG. We also want this IG. If this is clear, over. Now, I have got a unique way of explaining how I will tell the answer here. See, this IG is, I write the answer, then I will explain. First I get the answer. This IG is pi by 128 d power 4. This IG is 0.00686 d power 4. This IG is 0.00343 d power 4. This IG also equal to 0.00343 d power 4. Now, I will tell how to remember. How to remember. 1 minute. I will tell with full dictation. Those who are serious should write everything. It is your choice. Okay. G I not marked here. G. Okay, G here. Okay, I forgot to mark G only. Okay, everything over. Okay. Now I will dictate because I need some rest. That's why I got non-stop class I am taking. Now, I forgot one thing. I forgot to enter here. See, centroid this way is d by 2 d by 2. Why? Symmetry is there. But this way it is 2d by 3 pi. For semicircle, the distance to be located which is not midpoint is 2d by 3 pi. Even for quadrant also, it is same 2d by 3 pi, 2d by 3 pi. See, 2d by 3 pi, 2d by 3. This is lesser, this is more. This is lesser, this is more. This is lesser, this is more. This will come around how much percent I will tell you. If you take the full height here, it will come approximately, I don't know where is my calculator. It's here, 2d by 3 pi. 2 divided by 3 divided by 0.5. 2 divided by 3 divided by 0.5. It is 2 divided by 3 by 0.5 is How? 2d by 3 pi. 2 into 0.5 divided by 3 divided by shift pi. What is this one? 2 into diameter is 0.5 of diameter divided by 3 divided by shift pi. 0.1. How it is possible? 2 into diameter is 0.5 of diameter divided by 3 divided by shift pi. 0.106. 0.106 or 0.5 divided by 0.5 into 100. 21%. Or around, not 21%, it's actually a little more. 21% of this value. See, this is smaller, this is bigger. Why? More area here, more area here, more area here. This all already over. Now, see, semicircle, symmetry axis is there, midpoint. This way symmetry is not there, 2d by 3 pi. First of all, for everything you are right. For quadrant, there is no term called symmetry. So, 2d by 3 pi, 2d by 3 pi. This is clear for you. Now, moment of inertia, remember, corner I told, write for circle. Area, pi by 4d square, and moment of inertia, pi d power 4 by 64. You write it. It is required. Now do one thing. Area. Where I wrote area here? I forgot to write area here. Okay, 1 minute. Area I will write first. Semicircle area. Full area. Half of the circle. Circle is pi by 4. I not written, no? Not written. Pi by 8 of d square. Quadrant of circle. Area. Area. Circle pi by 4. Start from there. Circle pi by 4 diameter square. Semicircle, it's half. Pi by 8 diameter square. Quadrant, again half. Pi by 16 diameter square. This should be clear for you. Okay, then important is moment of inertia. See here. I will dictate. I forgot what I told. Thoroughly write all statements, something like that I told you. I don't remember. You write everything what I dictate. Now I'll dictate to how to avoid confusion. See, this I is 0.00686 d power 4. This I is pi by 128 d power 4. Here, both the i's are 0.003343 d power 4. Sometimes people get confusion. I will tell you what to do, how to remember it. See, first of all, remember, quadrant there is no symmetry. See, when it comes to quadrant, symmetry word is not there. Symmetry word is not there. The term symmetry does not exist for quadrant. But semicircle, there is one symmetry, one symmetrical axis, centroidal axis. Other is not symmetrical. So how to remember is, see, moment of, I will dictate now. First come to semicircle. See, this axis, that is perpendicular to the diameter here. See, you can make out. The symmetry axis, moment of inertia is exactly half of that for circle. Why? So circle is pi d power 4 by 64. So this axis, symmetry is there. Whatever is circle, half. So this is half of that for circle. Because why? Because symmetry is there. Because symmetry is there. You write symmetry is there. Red color you write there. You write using red color. Because half of that for circle, whatever is for circle answer, pi d power 4 by 64, it's half. Because symmetry is there. Now it's not fully clear. You write here. Half of that for circle because symmetry is there. So semicircle, if symmetry is there, the moment of inertia is half that for circle. Circle has got a pi. Same pi will come here. See, pi will come. Pi by 64 is pi by 128. Okay, this should be clear. This axis, symmetry is not there. When symmetry is not there, for semicircle, pi will not come. Remember, pi will come. It is simplified as a number. Actually, here also pi will come in the beginning. See, derivation, pi d power 4 by 128 minus pi by 8 of t square into 2d by 3 pi whole square, we have done it. But remember, answer finally, this axis, symmetry is not there. When symmetry is not there, pi will not come, a number will come into diameter. Always see diameter power 4. A number will come, that is diameter power 4. Here, symmetry is not there. That semicircle number is 0.00686. No pi, nothing. No pi. The pi is already considered in this number. So, for semicircle, when symmetry is there, moment of inertia is half that of the circle. But when symmetry is not there, moment of inertia is a number, decimal number. Pi will not come. No pi. 0.00686 into d power 4. Moment of inertia always d power 4. Okay. That is for semicircle. Come to quadrant. Quadrant. Area I already told. Quadrant, first of all, symmetry word only is not there. Therefore, for quadrant, once again number. What number? What number was there for semicircle when symmetry is not there? Half of that number. 0.00686, half is 0.00343. You can make a note here. See, this is 0.00686 is the number for semicircle. When symmetry is not there, half of that number. See, semicircle when symmetry is not there, 0.00686. Quadrant of a circle, there is no term called symmetry. What number is used for semicircle when symmetry is not there? It's half. 0.00686 is 0.00343 d power 4. I think this is sufficient. What all I told, go through 1,000 times. Okay. Now, I'll give numerical example fast. 1 minute. This all I remove now. Everything will remove. So that I'll go for fast numerical example. I will not waste time too much. One round for semicircle, one round for circle, as quadrant of a circle. Okay. Okay, start. Numerical example. See here, start. Numerical examples. Numerical examples. Example first for semicircle. Semicircle. 4 examples are there. I will put here example 1. A semicircle, see, this way. See correctly. This way semicircle. Example 1. Example 2 is a semicircle this way. See, nothing is left out. Example 3 is a semicircle this way. It can come this way. Example 4 is a semicircle this way. Okay. Start. Center. I will tell. First example, let diameter equal to 100 millimeter. Second example, let diameter equal to 120. Random numbers. This example, let diameter equal to 90. This example, let diameter equal to 140. Okay, random numbers. See, center here, center here, center here, center here. Okay, start. Area. I don't want to waste time. Area. Circle is pi by 4, pi by 8 of 100 square. Area here. Pi by 8 of 120 square. Area for this one. Area. Pi by 8 of 90 square. Area for this one. Pi by 8 of 140 square. That is not a problem. Okay, area over. Now centroid. See, centroid is here. This is axis of symmetry. See here. This is your axis of symmetry. This is not symmetrical. This distance is 2d by 3. Now write direct answer. 2d by 3 pi. 2d by 3 pi equal to 2 into diameter is 100 divided by 3 pi. Get the answer. Here, centroid is here. See, G. This is axis of symmetry. Axis of symmetry. At this distance is how much? Midpoint. Diameter 100, 100 by 2, 100 by 2. Here, diameter is 120. This is 120 by 2 and 120 by 2. Okay, centroid is here. This distance is 2d by 3 pi equal to 2 into diameter is 120 divided by 3 pi. Calculate here. See now here this is axis of symmetry. See, turned now, turned. So this is your axis of symmetry. So this one and this one both are diameter 90, 90 by 2, 90 by 2. Here this is axis of symmetry. See, axis of symmetry. This is diameter 140, 140 by 2 and 140 by 2. Now, centroid is here G, here centroid is here G. This distance is 2d by 3 pi, even here. This distance also is 2d by 3 pi. This 2d by 3 pi is 2 into 90, 90 divided by 3 pi, 90, not visible, okay, 2 into 90. This is 2 into diameter is 140 divided by 3 pi. This should be clear. Now important, see correctly. We want I about this axis, this IG we want. We also want this IG. We want, see one more axis here, forgot, right? We want this IG. Then we want somewhere here this IG. Here we want this IG. Then we want this IG. We want this IG. See, this IG. We want also this IG. Now make a note. There is, I am not wasting time now. This IG, this is symmetry axis. Pi by 128 of d power 4. Because if symmetry is there, half of circle are equal to pi by 128 of diameter is 100 power 4. Let me check the camera once. Suddenly, if it goes out of camera, problem. Okay, no problem. 120 power 4. But this IG is, this is not symmetrical. It is 0.00686 d power 4 or equal to 0.00686 into diameter is 100 power 4. Same way here. This IG is symmetrical. So directly I will put here now. Pi by 128 of, you write, you first write here. If you want to learn everything, you write pi by 128 of diameter power 4. Then write pi by 128 of 120 power 4. This IG, where it is? This IG, where is it? Somewhere I want to write. This IG, I write here. See. This IG is this IG. This is not symmetrical. So it is, you write 0.00686 d power 4 equal to 0.00686 into diameter is 120 power 4. It has gone that side, adjust it. Okay, gone that side. Okay, now here, this is axis of symmetry. Therefore, pi by 128 of, you write the formula, diameter power 4 is 90 power 4. But this IG is, this is not symmetrical. Point, you write, if you are serious, point once in a lifetime, 0.00686 diameter power 4 is 0.00, how much time I have to write? 686 diameter is What is the diameter? 90 into 90 power 4. Here, this is symmetrical axis. So, pi by 128 of, you write d power 4, that is of 140 power 4. Whereas this Ig, this is not symmetrical, 0.00686. You write d power 4, then write diameter is 140 into 140 power 4. Area written? Area written. Okay, this will complete for semicircle. Now I will do for quadrant of a circle. 4 examples for quadrant. Okay. Right here, numerical example for quadrant of a circle. Again 4 examples. Okay, I'll write here. Example 1, see how I did earlier, same way. This way. Imagine diameter you cannot see. See, this is diameter. Diameter equal to 70. Okay. Second example, this way over, this way. See, everything is covered here. This way. Second example. Let diameter equal to 50. Third example. This way, quadrant. Center is here. Center is here. Center is here. Diameter equal to 115. Fourth example here. Let diameter equal to 150. Okay. 4 random numbers. Center is here. Okay, right, fast. Area. Circle is pi by 4 diameter square. Semicircle is pi by 8 diameter square. Quadrant is pi by 16 diameter square. You write that way. You write pi by 16 diameter square, then write 70 square. At least one question write. This area, pi by 16 of 50 square. This area, pi by 16 of 115 square. This area, pi by 16 of 150 square. Okay, then locate centroid. Somewhere here, somewhere here, somewhere here, somewhere here. Now, remember, this is 2d by 3 pi. This also is 2d by 3 pi. Next time I won't write. You should write equal to equal. This is 2 into 70 by 3 pi equal to 2 into 70 by 3 pi. Right here. This is right 2d by 3 pi. You write 2d by 3 pi. Write the formula, then write equal to 2 into 50 divided by 3 pi equal to, after writing formula, 2d by 3 pi, 2 into 50 divided by 3 pi. Here. Okay. Write the formula, 2d by 3 pi, 2 into 115 divided by 3 pi, 2 into 115 divided by 3 pi. Here. Right. This is, and this one. 2d by 3 pi, right, then write 2 into 150 divided by 3 pi, 2 into 150 divided by 3 pi. This much you make ready. If you don't write properly, you are losing. That's all I can tell. Now, one centroidal axis here, 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 one axis here. Now, start. First of all, for semicircle, there is no term called symmetry. So, not symmetrical means, semicircle not symmetry means 0.00686. So, this Ig is 0.00686. 686, sorry, 686 not, 0.00686 for semicircle, it is half, 0.00343 d power 4, and even this Ig also 0.00343 d power 4. Substitute equal to 0.00343 into 70 power 4, 0.00343 into 70 power 4. Now you should write this Ig and this Ig both are same. You don't write same, you write separately. If you want to learn everything, both the places you write 0.00343. If you don't write properly and save time like me, you are losing. Answer. Both Igs are same. Both Ig are 0.00343 into 50 power 4. Here, see, this Ig, wait right here now, okay, this Ig and this Ig, both Igs are, this Ig and this Ig, you write separately, you write here 0.00343, 0.00343 d power 4, substitute for both of them, both are same, equal to 0.00343 into diameter is 115 power 4. Here, this Ig and this Ig, both Igs are same, don't write same. In spite of my warning, some will not write. You write here this Ig 0.00343 d power 4, 0.00343 d power 4, substitute, and one fair copy can't you make? Both are equal to 0.00343 into diameter is 150 power 4. Okay. Now semicircle and circle are over. Sorry, circle, semicircle, quadrant over, triangle, all types over, rectangles over, nothing further. Now I am going to end this class here now, over. All I told you, complete class what I wrote is, see, today's class fully what I wrote is nothing but later when you find moment of inertia, I about any axis, you write what? At that time you write, see, at that time you write what? Ig plus A into H square. This term, today's class full I explained is this term, including location of CG. Okay, thoroughly study, make everything fair copy, and next class I will go for example for parallax theorem for 1 by 1 unit. See, I will put some two axes here, one A, B and CD. There I will put in the Q, rectangle, triangle, etc. In the Q, I will call 1 by 1. Come here, stand here, sit here. I will finish you and send you outside. So next class is equally important, but next time when such things happens, I will not explain why 0.00343 all. I won't explain. If you don't understand, some will tell how you got it. Leave the class. Sorry to tell this all these things, but I got the right when this much patience I took the class, and if you don't follow, you don't deserve to study from me. Oh. But this is only for those who are not serious. Those who are serious, they will understand everything. Okay, thank you. We'll meet in the next class.